This video is on key features of a function. These are examples 7 and 8 without context. 7 says, given the graph of h of x to the right, identify and describe the following. So h of x is the same as f of x or g of x. It just lets you know that we are dealing with h instead of an f or a g. It's in case we have multiple graphs on the same coordinate plane, we can distinguish between the different functions. So the first question says h of 4 equals blank. So this is, instead of it saying h of x, it says h of 4. That means that the x was replaced with the 4. That means x is 4. So if we go to the graph, we go to the x value of 4, we need to know the y value of that location. So we would go to the graph and we'd see the coordinate of 4, 2. So the h of 4 is equal to 2. B asks for h of -1. So again, x is -1 because it is replaced, x is replaced with a -1. So we need to know the y value. So if we look for the coordinate on the function itself at x value of -1. So we'll go to the x of -1 and then go to the function. We get the coordinate of -1, -3. So h of -1 is equal to -3. C asks us h of x equals -1. Well, going back to here, h of x, x is not told to us. That means that the -1 represents the y value. So the y value, just like on A here, the 2 was the y value, the -1 is the y value. We need to know what the x value of the coordinate is. So we go to the y value of -1 and we see how many times it might cross. So at the -1, we go to the left and it hits the function at -5, -1. And we also go to the right and it crosses at 1, -1. So the y value is -1. We need to know the x value. So it crossed twice, or it hit twice. So there are two x values. X is equal to, the first one was at -5, -1. So the x was -5. And the other one was at 1, -1. So the y was already -1. The x is equal to 1. Okay. On the next question, it says h of x is equal to 2. So again, the x is not known. So h of x, we are not told what the x is. We are told what the y is. So if we go to the y value of 2, the y value of 2 is here, and we want to go to the right-hand side. And we see a coordinate that it does cross at 4, 2, so we know that the x value is 4. But what about on the left-hand side? Now, we do not see it crossing over here. However, you have to see that this is, in fact, an arrow. That means that this graph will continue to move upwards. So at this 2, it will cross eventually. We just don't see it yet. So that means that we need to continue this graph so we can see it all. So we can see that from this point down at the bottom, it went up 1 and then left 1. Up 1, left 1, up 1, left 1, up 1, left 1. So if we do that again, so we're going to go up to 1 and then left to -7. Well, then we're going to do it again, up to 2 and then left to -8. So this is a continuation of this graph because this graph will continue. So now that we see that it crossed at, so the y value of 2 was at 4, 2, and also at -8, 2. So we have two answers. X is equal to -8 and x is equal to 4. So we do have to be careful just because we didn't automatically see it crossing on the left-hand side. This graph had an arrow, which means that it extends indefinitely. Okay. The next question says identify the y-intercept, which is where the graph crosses the y-axis. The graph is crossing the y-axis here, which is at 0, -2. Then it asks for identify the x-intercept or intercepts, because there could be multiple. So when it crosses the x-axis, so starting from the left, it crosses the x-axis at -6, 0. And then it does it again at 2, 0. So our two x-intercepts are at -6, 0 and 2, 0. Next says find the minimum coordinate and value. So the coordinate is going to be the lowest point on the graph since it says minimum. And the value will be the y value of that coordinate. So we look at the smallest point or the lowest point on the graph. And that is at a coordinate of -2, -4. And then the value is y is equal to the -4. That helps us with our range to know that there is a smallest value because it does have a start or a stop point. Okay, the next question says determine the domain. Domain I'm going to put off to the side over here just so I can make notes to myself. Domain is my x values. So I know that there should be a number that's on the left and then a number that's on the right. And I know that it should be in between those two numbers. Now I don't know if they're equal to yet because I don't know if it's solid, if there's arrows, what's going on. Okay, so I'm making this off to myself so I can write out my answer in just a moment. All right, so I'm going to look for the domain. It's to the left side, so the farthest thing on the left of this graph. So starting on the left, there's actually an arrow there. It's not a coordinate, it's an arrow. That's important to distinguish. So I would write the word arrow right here. Then I want to go to the far right-hand side of the graph. So the farthest right, I'm going to go to the farthest edge, and there actually is something there, which is also an arrow. Now, if I recall, arrows I don't want to actually use, so I'm going to erase the word arrow and its inequality. And on the other side, I'm going to erase the word arrow and its inequality. I'm just left with x. That means that I have all of the numbers in the x, because this arrow says it's going to the left forever, and this arrow says it's going to the right forever. That means that the domain is x is an element of all real numbers. So my answer will be x is an element of all real numbers. Okay. Next, I'm going to do the range. Put this back to where it was. Okay. So range, I know, again, I'm going to put it off to the side here just so I can write little notes to myself. I know the range or the y value, so that's the bottom number, and it goes to the top number. So I know it's going to be between the bottom and the top. So I know my inequalities will look like this because it's between the smallest and the largest. Okay, so I'm going to look at the bottom part of the graph. So the coordinate plane, there's nothing down here, so I'm going to move it up a little bit. And I do see a bottom coordinate, so I'm going to actually put a number there. I need the y value of this coordinate, which is at -4. Which helps us because that was the y value of the minimum. That matches. Now, it is at -4, so I do want to put the equal to sign. So -4 is less than or equal to y. Okay, then I go to the top part of the graph. Okay, so I'm at the coordinate plane, and there's nothing physically at the top edge of this, so I need to come down a little bit, and I see that there is something at here, at around 4, but that is an arrow. It's not the number 4, it's an arrow. So I would have to write the word arrow. Now, going back to my domain and range, I know that I can't have arrow in my answer, so I would erase the word arrow and its inequality, and I'm left with -4 is less than or equal to y. That actually is the final answer. So because it's not another arrow, I would keep it just like this. So -4 is less than or equal to y. And again, you can also rewrite this with the y first, but if you write it backwards, you have to flip the inequality because it says -4 is less than y, so we have to flip that to say y is greater than or equal to -4. Now, if we think about that, it means that everything is going up. It's bigger than -4. And all of these y values on this graph are in fact bigger than -4. And again, this stuff in the middle was just so that I could make notes to myself, so it helps out with writing out my domain and range. The last part of this problem is asking for the determine the intervals for increasing, decreasing. Again, this goes back to the intervals of the domain, which is all real numbers. So we know we're going to use all of the numbers in the problem. So we're going to use the x's and the x's. So I need to determine if our graph is increasing or decreasing first. I'm going to do my highlighters. I'm going to highlight increasing in orange and then decreasing in green. So I need to first determine what's happening. So domain is left to right. So I'm going to start at the farthest thing to the left. And as my graph as I trace it, I'm going to go down first. So that's my decreasing. So I'm actually going to start highlighting in green first. So I do in fact have an arrow up here. So I will remember to put that arrow. I'm going to go in green, decrease, 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 and then it turns. So that's when it has to turn to orange because now it's going in a different direction. So I'm going to increase in orange, and then I come to an arrow. So I'm going to put my little arrow here. This is the turning spot. I'm just going to mark that turning spot. All right, so for my green, or since I did green first, I will actually write the green first. What is the first part of the green? Well, the first part of the green, I'm going to go ahead and put my inequalities in here because I know it's going to be between two numbers. The first part of my green is an arrow, so I'm going to write out the word arrow. And the last part of the green, the x value of this location was at -2. Okay. All right, and then I have to go to orange. So what is the first part of the orange? Well, the first part of the orange was the ending of the green, which was also at that -2. So these numbers should match. The turning point numbers should match. Then what is the last part of the orange? It was an arrow. Okay, and going back to remembering domain and range, I cannot keep the word arrow, so I'm going to take the word arrow, erase it, and its inequality. And on the decreasing, take the word arrow, erase it, and its inequality. And what we're left with is our answer. And as a reminder, these are not equal to, because at that turning point, it is neither increasing or decreasing. It is turning at that location. So that is your increasing and decreasing intervals. And it does not matter which one you actually write first. I went with decreasing first because that was the green, and that was just because it happened first, so I write that value first. Question 8 also has no context, so we are going to be using this graph only. We are given the graph of p of x to the right. So again, just another way of noting a different function. It's the same type of information, so we are going to find the answers the same way. We want to find p of 3. So again, the x value is 3. So at the x value of 3, we're going to go find where it hits the function. X value of 3 is about the y value of 3.5. So the x value would be 3. The y value would be approximately 3.5. P of -1 is the next question. So again, P of x, P of -1, x is -1. So we go to the x value of -1 and go to the draw to the function, which is going up. And we want that coordinate, -1, comma, about 7.5. So we already have the -1. We need to write out the 7.5. Okay. C says P of x equals 6. So P of x, x has not been told to us. We are told then the y value. So we go to the y value of 6. So go to the y value of 6. And we find every location that it might hit. So we have to go to the left, which it does hit on the left. and it doesn't hit again. So it does hit at that negative 2 comma 6. So x is equal to negative 2. Go back to the 6, go to the right now. And it does hit on the right hand side as well at 2 comma 6. So we also have, and x is equal to positive 2. Now the graph does not turn back around because of these arrows are saying they're just going to keep going down forever. So it's not going to come back up and it won't hit that 6 again. D asks you to identify the y-intercept. So it's crossing the y-axis at 0, 8. It is a coordinate 0, 8. E asks us to identify the x-intercept or intercepts. So the x-axis, starting over on the left, it crosses the x-axis at negative 4, 0. It is a coordinate. Keep going until, let's see if it crosses again, and it does hit again at 4, 0. And 4, 0. Our two x-intercepts are at negative 4, 0 and 4, 0. F says find the maximum coordinate and value. So maximum tells us that it's at the highest point on the graph. So we look at the top of the graph and we see we have a coordinate up here, which is the highest point, which is at 0, 8, which is the same as your y-intercept, which that's just a coincidence that that happened. And it also says find the value. So our value is always the y of that coordinate. So the y value, the y maximum, is y equals 8. And that helps us with our range. Okay, determine the domain. I am again going to write out just off to the side here my x in the middle, and I know that I have to have a smallest number and a largest number with my inequalities. My inequalities will always look like this with domain because I know it's the smallest is going to be smaller, and then my largest is going to be the largest. Okay, so we want to look at the farthest thing on the left of our graph. So on the edge here, we have an arrow. I want to go to the farthest right. So farthest right edge, there is something here. It is an arrow. I always look on the edges and determine if there's actually something there. If it's not, then I move into the graph as much as I need to. So going back to this domain, we see the word arrow. We know we can't have the word arrow, so we erase it and its inequality. The word arrow, erase it and its inequality. So we're just left with the letter x. That means that because it went left and right forever, that it's going to be an element of all real numbers. I know this doesn't look like it's graphing left, but this is actually going more of a southwest, which the west is going left, the south is going down. So it is going in two directions because it's diagonal. So our answer for domain would be x is an element of all real numbers, or x is all real numbers. Okay, for the range, we're going to do the same thing. We're going to go to the y values though. So I'm going to erase the markings. So I'm going to put my y in the middle, and I know I'm going to have the smallest number and then the biggest number. Okay, so looking at, so I know my inequalities are here. I don't know if they're equal to at the moment because I don't know if they're solid or not. So we want the lowest point on the graph. So if we go down to the bottom of this graph, we do have something there. It's actually an arrow. So there's an arrow on both sides, but I only have to circle one. There is an arrow. So I would put the lowest thing is arrow. Now I'm going to go up to the top part of the graph. So at the top part of the graph, there's actually nothing at the very top. So I need to come down some. So coming into the graph, and I see that it does come to this top here. So that is the y value of 8, which does make sense because that was our maximum coordinate. So it is at 8 because it's solid there, so we would put y is less than or equal to 8. Okay, so I'm going to come back to arrow. I know I'm going to erase that and take off its inequality. And we're left with y is less than or equal to 8. And that is our final answer for our range. Y is less than or equal to 8. So I'm going to erase that and put it in red. Y is less than or equal to 8. and we don't have to rewrite it because the y is already first. This is saying that all of the graph is, all the y values are smaller than 8. So we can see that the 9 is never touched, but all of these other y values are. Okay, our last question says determine the intervals for increasing, decreasing. Again, this is intervals of the domain, so we know we're going to be focusing on the x's. So I'll put my x, and I'll put my x. Put my inequalities, because I know it's going to be the smallest to the largest, and the smallest to the largest. So I'll go ahead and put those there. All right, I will also do my highlighters. I will highlight increasing in orange, and I'll highlight my decreasing in green. First thing I need to look at is determining if it's increasing or decreasing first. So it's the domain, so I'm going to start on the farthest thing on the left. So the farthest on the left is here, and as I trace it, my graph is going up. My pen is going up. So I'm going to increase first. So I'm going to actually start with orange highlight. So I do have an arrow here. I'm going to keep that there. And I'm going to start highlighting in orange. So it's still going up, it's still going up, it's still going up, still going up. And then it starts to turn. So now it's turning. I am now at a turning point. So now I have to switch colors to green because it's now going to decrease. So it's going down, 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 and it comes to an arrow. So that means it's going to keep going down. So it doesn't turn back up, so it's not going to turn back into orange. So our turning point was here. All right, so I did orange first, so I'm going to do orange first over here. What is the first thing on the orange? The first thing on the orange was an arrow. What was the last thing on the orange? Last thing on the orange was this location, which is the x value of 0. Then I go to the green. What is the first thing on the green? It is that turning point, which is that x value of 0. And again, these turning point x's should match. What is the last thing on the green? The last thing on the green was an arrow. So now I go back in here and I will erase the word arrow and its inequality, erase the word arrow and its inequality, and then I should be left with my final answer. So the interval of increasing is everything that is less than 0. So on the left hand side, if I start from the left, I'm always going to go up the graph. I know it's pointing down, but again, it's not talking about the y's. It's the graph, as the graph reads from left to right. This graph would be going up until it hit the y-intercept, and then the graph actually comes down. So anything bigger than 0 is when the graph is decreasing.